You have probably heard people say that you should be cautious with certain exercises like deadlifts and very heavy lifting, especially 1-rep max attempts. These things are thought to cause significant central nervous system fatigue. They might fry your CNS and therefore disrupt not just that exercise, but your whole body, causing systemic central fatigue that is very difficult to recover from and might warrant a deload week. All of this is based on a completely incorrect understanding of what CNS fatigue is, how it works, and how it affects your training. Let's look at the facts. First, what is CNS fatigue? CNS fatigue refers to a reduced activation of the central nervous system of your muscles. So the brain and the spinal cord together form the CNS, the central nervous system. The brain sends signals to your muscles down via the spinal cord, which activate a motor neuron, which then excites or activates certain muscle fibers that are attached to it, which are called a motor unit together. And they activate your muscles. So the brain is essentially the driver, if you will, of your muscles, which you can see as the car. And CNS fatigue refers to fatigue in the driver, so it's reduced excitability or reduced excitation of the muscles in central origin. So any suppression of the central nervous system results in lower muscle activity levels and lower force production, even though the muscles themselves might be completely fine. The causes of CNS fatigue are widely misunderstood. It's commonly believed that very high intensity lifting, like 1RM attempts, are significantly fatiguing for the CNS. In reality, the central nervous system is mostly fatigued by endurance exercise, and it's the duration of exercise which strongly predicts the amount of CNS fatigue rather than the intensity. In fact, it is mostly endurance training in general that causes CNS fatigue. Strength training causes significantly less CNS fatigue than endurance training. Second, it is commonly believed that the amount of muscle mass is a strong predictor of the amount of CNS fatigue. In reality, this is not the case. For example, deadlifts, which are notorious for frying the CNS, in reality are no more fatiguing in the neuromuscular sense at least than squats and bench presses. Moreover, leg extensions can produce just as much neuromuscular fatigue as leg presses. The contraction type, interestingly, is a lot more important than the amount of muscle mass involved. For example, biceps curls, which are one of the smallest muscles in the body, can cause massive CNS fatigue if you do them with eccentric muscle contractions. The CNS fatigue in this case can last for days. In fact, in general, the amount of CNS fatigue that we suffer is very strongly correlated with the amount of muscle damage that we inflict. At this point, you might be wondering, hey, it seems like most of the things that cause CNS fatigue are also the things that cause local muscle fatigue. So what's going on there? Indeed, most central nervous system fatigue is not actually central in nature. It's very paradoxical, but most CNS fatigue is actually local in nature. Fatigue originates in the motor neuron. The motor neuron is located inside the spinal cord, therefore it is part of the central nervous system. However, its axon originates like a tentacle outward and is part of the peripheral nervous system. And it only affects one muscle group. In fact, it only affects the muscle fibers that are connected to that motor neuron, forming together a motor unit, which are only a few fibers of one muscle group. So the fatigue is local, it's regional, it just affects that one muscle group. In fact, only these fibers that are innervated by that motor neuron. So most of the fatigue, most of the CNS fatigue is actually local in nature. The effects only affect one muscle even though it is part of the central nervous system. At this point, when I explain this to my students, they often ask, if central nervous system fatigue is not central in nature, what does cause central fatigue? That is a very good question. An even better question is, does central fatigue even exist? One research paper looked specifically at this question, and they concluded the forced behavior commonly attributed to central fatigue could be explained solely by peripheral factors, and questions the very need for the existence of central fatigue. It makes perfect sense if you think about it that central fatigue doesn't occur very easily because the brain is much more like a computer than muscle. Muscle can tear, it can suffer damage, it can suffer metabolic stress. That is not so much the case for the brain. The brain is more like software. If you open an app and close it and you open it again and you close it, you keep doing that all the time, you just get the same input-output. It doesn't fatigue. Like a computer doesn't really fatigue in the sense that a muscle does. It doesn't run out of energy, it doesn't start tearing up. So the mechanical wear and tear of muscle fibers and the metabolic effects, they are much more pronounced in muscle tissue than in the brain. So is there actually any central fatigue at all during strength training? Based on systematic review and meta-analysis of 52 studies, there isn't. The researchers concluded Overall, the findings do not support the existence of a general non-local muscle fatigue effect. However, when examining specific types of performance outcomes, there may be a specific effect upon endurance-based outcomes. So basically, they concluded that when you look at workouts where you train multiple muscle groups, training one muscle group does not affect the other. And you can easily verify this for yourself in the gym. If you're very motivated and you're doing squats, it does not affect your biceps curls afterwards. If you're training triceps, it doesn't affect your biceps curls either. Strength training is very much a local thing. You train one muscle group, that muscle group fatigues, that muscle group experiences tension, and that muscle group grows. It doesn't affect what happens to any other muscle group. Endurance training is much more central. It affects the heart, the cardiac system, the cardiorespiratory system, so the effects in general are much more systemic and they can affect the whole body as a consequence. However, strength training is very much just muscular in nature, which is very local and regional. Now, you may protest that at the end of a long workout, you feel fatigued and your performance does indeed suffer, even in muscle groups that you have not trained. That might be the case, but this fatigue is not neuromuscular in nature. It is a psychological fatigue, mental fatigue. Humans in general are effort averse, and most of the central fatigue we experience is not neuromuscular, but psychological. The feeling of fatigue in general originates from doing things that are very difficult to do and that we don't inherently like doing. If you think, for example, about visiting family members that you don't like that much, or you think of driving a car for hours at a time, these things can also be exhausting, but clearly they don't cause neuromuscular fatigue or any physical fatigue in general. So the sensation of fatigue is not the same as neuromuscular fatigue. In fact, this is a general theme of what I teach. Your feelings in the gym are just that, feelings. They don't necessarily correspond to any physical reality or what you're physically doing. If you're interested in psychology in more detail, as well as strategies to reduce the mental fatigue you experience in the gym, you can check out my book, The Science of Self-Control. Let's sum up what we learned and what this means in practice. Central nervous system fatigue is very real, but it's mostly local in effect. Don't be fooled by the name. Just because it technically originates in the central nervous system doesn't mean the effects are central or systemic in the body in nature. Most of the effects are specific to a motor neuron, they strongly correlate with muscle damage, and therefore they affect only one muscle group. Training one muscle group does not fatigue any other muscle groups, not in a neuromuscular sense at least. Most of the fatigue you experience in the gym is mental fatigue. Mental fatigue is very different from neuromuscular fatigue. Neuromuscular physical fatigue is the actual physical fatigue, which is a reduction in force output by the musculature that you're using. Mental fatigue is the sensation of feeling tired, which you can also get from a lot of things that don't make you physically fatigued. The most important thing to take home from this is that the physical fatigue you feel in the gym is not an indication of overtraining or CNS fatigue or the fact that you are damaging your body somehow. It is normal that humans are effort averse, and it is normal that your body does not like you putting a heavy iron on your back and squatting until you cannot do any more. These are not things that we have evolutionarily wired to do. We are wired to conserve energy, not to expend energy, and to be comfortable, not to push past our comfort zone. But these things, pushing past your comfort zone, ignoring fatigue, and pushing when your body is telling you not to train anymore, those are exactly the things that separate the winners from the losers, and those are the things that make weak people become strong. Obtaining physical strength requires mental strength. If you like this type of evidence-based fitness content, I'd be honored if you like and subscribe.